Coordinate geometry may sound tough, but it just means that we're talking about representing points, lines, or shapes on a graph. That's nothing new, right? In this lesson, we'll go over coordinate geometry basics as well as a review of line segments. Let's start with plotting a point. We have point A at 2, 3, and point B at -1, -1. Starting with point A, place your pencil at the origin, which is the point where the x and y axis meet, and count 2 spaces to the right, since we need to get to +2. Next, move your pencil up 3 spaces, since our point on the y-axis is 3. Label this as point A. To plot point B, go back and start at the origin again. For -1 on the x-axis, move your pencil 1 space to the left. Then, for -1 on the y-axis, move 1 space down. You're now at the point -1, -1. Label that point as B. Now that we've plotted our points, let's find the distance between these 2 points. You may have learned a few different ways to find distance on a graph, but let's focus on the distance formula. The distance formula says that the distance between 2 points on a graph is equal to the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared, all under a square root sign. Let's plug in our numbers for this graph. Label point A, 2, 3, as x2, y2, and point B, -1, -1, as x1, y1. Plugging those into our equation, we get that the distance between points A and B is equal to the square root of the quantity 2 minus -1 squared plus the quantity 3 minus -1 squared. We want to simplify, so we have 2 plus 1 squared plus 3 plus 1 squared, which then becomes 3 squared plus 4 squared, or 9 plus 16. Our distance is the square root of 25, which works out to 5. So, the distance between our 2 points is equal to 5. While graphs show various points along the x and y axes, number lines represent how numbers are ordered. Number lines are another type of problem that can appear on the SAT math sections. So here's a quick review. Number lines are horizontal representation of any range of numbers. As you move to the right on a number line, the numbers get bigger, and as you move to the left, the numbers get smaller. Let's apply this information to a problem you can expect to find on the SAT. On the number line shown, the tick marks are evenly spaced between 0 and 1. What is the value of A? Our answer choices are A, 1/5, B, 1/4, C, 10, and D, 25. Since we know that the tick marks on the number line are evenly spaced, we can figure out the distance between each tick mark by using the equation jump distance equals the total distance divided by the number of jumps it takes to get from one number to another. So let's count the number of jumps between 0 and 1. Starting at 0 and ending at 1, we have 5 spaces. We also know that the total distance between 0 and 1 is 1. Plugging into our formula for finding the distance, we're going to divide the total distance, 1, by the number of jumps, 5. So, each tick mark represents 1/5. This lets us know that a to the -1/2 is equal to 1/5. Now we need to deal with the exponent. Let's start with the minus sign. A negative exponent means 1 over the number or variable of your exponent. So, a to the -1/2 is the same thing as 1 over a to the 1/2, which means 1 over a to the 1/2 equals 1 over 5. Since the two sides are equal and the numerators are the same, the denominators must also be the same, which means a to the 1/2 equals 5. We still have an exponent, so let's figure that out. We have a to the 1/2, but we want a by itself, which means we want a to the 1. That means we need to multiply the exponents on both sides of the equation by 2 to get a to the 1/2 to the 2 equals 5 to the 2. That gives us a to the 2 over 2 equals 5 squared, or a equals 25. It would be good to remember that a to the 1/2 means the square root of a. If the square root of a equals 5, then a equals 5 squared, or 25. Either way, we know the answer is D. Remember, if you aren't confident with your algebra in a problem like this, you can always back solve. Let's try that this time with a calculator. We'll back up to the point where we found a to the negative 1/2 equals 1/5. Since we're using a calculator, it will be easier to convert 1/5 to a decimal. This is a good one to just know, but if you need to use your calculator, you'll find that 1/5 is equal to 0.2. So when we plug the answer choices into our calculator, we'll need to get 0.2. We're looking for the value of a to the negative 1/2 to equal 1/5, or 0.2. As always with back solving, let's start with one of the two middle numbers. In this case, let's start with C, 10. If we plug in a equals 10, we get 10 to the negative 1/2. Plugging into our calculator, we get 0.316. Since we need the answer closer to 0.2, a needs to be bigger. So cross out answer choice C. If it wasn't clear to you that a needs to be bigger, don't worry. And don't waste time trying to figure that out. Plug in another number. If you plugged in choice B, you would quickly see that you were moving in the wrong direction. Let's try a larger value for a. Let's plug answer choice D, 25, in for a. If we plug in a equals 25, we get that 25 to the negative 1/2 equals 0.2, or 1/5. Bingo! You can circle answer choice D, 25. This was really great practice for the basics of coordinate geometry and line segments. There's a lot of little details that need your attention, but the more you practice, the better you'll get at picking up the clues.